Hey guys, Forex here, hope you're all well. What you're looking at in front of you is a Spectrum Plus 48K. I got this from eBay as untested, which is probably means it don't work. That's eBay listing talk for untested equals don't work. So yeah, if we take a look at this Spectrum Plus, it's not in bad condition. It just needs a really good clean. So what I'm going to do to this is strip it down and give it a clean like I do all my systems. And I'll show you the enter key. The enter key is sticky. That's quite common. They do go like that after time. You just give it a nice the system a full clean, and then you can oil the enter key and it stops it sticking. But first, there's something alarming happening to this system. If I pick it up and move it about, I don't know whether you can hear that. There's something inside rattling. So before I even power it on, I want to get in the system and have a look to see what that is, because if it's a component that's fallen off, I want to try and get it now before I power it on. So yeah, give me 5 minutes to set up and we'll get in this thing. Okay, to get in this system it's pretty easy. There's 8 screws. There's 1, 2, 3 on this side. There's one at the bottom in the center. There's another 3 on this side, 1, 2, 3, and finally this sneaky one here that I always forget. So okay, I've taken the screws out. The way you open these things is like this. The reason for that is because round about here there'll be a ribbon cable, and round about here there'll be a ribbon cable as well. So you open it like this, and then you can grab the ribbon cables and just pull them out. So what I'll do is I'll just tilt this up and show you those ribbon cables that you have to remove. So if I just go like this, oh, you've got to be shitting me. Happy times. Yeah, that keyboard membrane snapped. That's looking like a new keyboard membrane, I'm afraid. Oh dear. Wait, this is missing. Where's the reset button? Where's the reset button? There should be a reset button. Where's the reset button? Yeah, here, look. You can see where it was soldered in. So where's the reset button? Oh, this is just getting better, guys. This gets better every single second. Oh dear. What's that? Oh, there's the thing that was rattling. Oh, brilliant! We found the thing that's rattling. Where's that come from? Where's that come from? That's, oh, there it is. There it is. Just there. Yeah, that's it. That's it. Just there, look. That's the piece of plastic that's fell off. And it looks like someone's tried to glue it before. Oh, that's just brilliant, isn't it? Absolutely brilliant. Whoever did this did a fantastic job. Oh, what an absolute. Oh. Why you remove the reset button? Oh, this is actually quite comical. Sorry, I had to stop the camera, guys. I just had a laughing fit. No, it's just that when I see stuff like this, it makes me laugh. Some people get angry, but I just laugh. I don't know why, because I've got a sick mind probably. It just makes me laugh when I see people oh dear. Now I can only surmise what's happened here, but probably what happened was the reset switch failed, and the person who had this opened it up to remove the reset switch, and doing that they may have opened it up and broke the keyboard membrane. Also, what they tried to do is probably fix this as well. This probably went, and they tried to fix that because you can see like remnants of super glue on there. So they've had a go at that and it's just broke off again. Now, what I'm going to do before I order a new keyboard membrane is I want to make sure that this actually works first. You know, I don't want to be paying, what, £19 for a new keyboard membrane and the system don't work. I'm pretty much wasting my money. But what I can do in the meantime is test this board. I can also strip this down and give it a really good clean. Because even if I don't get this board working, I've still got the outer shell, which is in fairly decent condition, and I can always use it as a spare. So what I'm going to do now is strip this system down and give it a good clean, and then we'll test the Spectrum inside. So okay, let's get the bottom case out so we can get ready for cleaning. Now it's super easy to get the board out. You just pull it out, no screws. You take these like little wing things off. These are springs. They just hold these feet in. We'll take those out as well, and that's it. That's the bottom part, all stripped, ready for soaking. So okay, let's get the back plate and the broken keyboard membrane off. There's 1, 2, 3, 4 screws there, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 screws on the back plate. Okay, that's the membrane retainer brackets removed. Let's remove the back plate, and as you can see, we have the membrane underneath. Now this is a shame, guys, because this membrane's not in bad condition. It just needs a clean, just a wipe down. It's just a shame about some idiot broke the membrane. So yeah, I'll have to get a new one of those. Bummer. So yeah, what I'll do next is remove the rubber plungers. Now this is what gives you the feedback when you push it. It's what pushes the key, acts like a spring. And remove that. And as you can see, we now have access to the bottom of the keys. So what I'm going to do is turn this round now, and I'm going to start removing the top parts of the keys. Now okay, to remove the keys, it's actually very easy. You just take your finger, the back of your finger, and you push it through the hole there like that, and that pushes the key upwards, and then you can grab it either side and just pull it out. What I'll try and do is I'll try and demonstrate that with a, put that on a bottle there like that, just to push that up, and then I'll just grab it, and you can see how easy it comes off. Easy peasy, lemon squeezy. Now that should fall off. There you go, there's the back bit to the key. So yeah, I'm just going to continue, get all the rest of the keys off. Okay, that's the keyboard stripped down, all the keys removed, all the backing keys, mounts have been removed. Ready to get this in soak now. What I'm going to do first is I'm going to get a standing knife and just take this off, because this is paper and I don't think it would survive in water, so I'm just going to whip that off. But yeah, all these along with the lower case can get in soak now. Okay, as you can see, I have the upper part of the case and the lower part of the case in soak. I've also got the keys and the key mounts in soak as well. So I'll leave those for about 20 minutes and then come back and give them a good scrub and a clean. What I can do now while I'm waiting for this is I can test the actual Spectrum PCB and see if that works or not. Okay, before I hook up power to this, there's a few checks I want to do now. I've gone over the board and give it a visual inspection, and one of the things that stands out to me straight away is if we look at the bottom rungs, one of them's been replaced. So yeah, this system's been repaired in the past. It's not uncommon to find Spectrums like this, to see RAMs that have been replaced. What I'm going to do now is I'm going to take my multimeter and I'm going to carry out a series of checks, continuity and resistance checks. Now all these checks that I'm going to be doing are related to a video made by a really top repair guy called JoulesperCoulomb. He pretty much knows the Spectrum 48K and 128s and plus 2s inside out, and he does these checks before he powers up any like Spectrum like this, just to make sure that there's nothing irregular or anything like that. So I'm going to carry out those checks now using my multimeter. What I'll do is I'll put a link to the video where he shows you how to carry out these checks, and I'll also link in his YouTube channel. So yeah, that's what I'm going to do next. So okay, I've taken my multimeter, I've did all the tests that JoulesperCoulomb states in his video, and everything's come back okay. Everything seems to be fine. What I'm going to do now is give it a first initial power on. Now as you can see, I have a couple of connectors connected to the voltage input and the ground input on the voltage regulator. That's because I don't have a barrel jack to plug in there, so I've just tapped straight into the voltage regulator on the input. Now in JoulesperCoulomb's video, he says if you have a bench power supply, which I do, is set it to 9 volts on the output and 750 milliamps current limit, and that's what that is. It's a current limit set to 750 milliamps. He says when you power this thing on, it shouldn't really take more than 600 milliamps with nothing connected to it. So I'm going to try that. If it starts to draw anything more than 750 milliamps, my power supply output will switch off, and then I'll know there's something seriously wrong with the system. So let's power on. Fingers crossed we don't get any magic smoke, and see what we start to draw. And we're drawing 500, 600 milliamps. It's settling down a bit now, so 500 and about 80 plus or minus 20 milliamps. So yeah, that looks to be okay. It's not tripped over current. So yeah, what I'm going to do now is I'll just power this off, and what I'll do now is I'll hook up a RF connector. I'll connect it to my TV and we'll see if this thing tunes in okay. So okay, got some good news. We may have got lucky on this one. What I've done is I've hooked up the RF cable to the RF modulator. I tuned in the TV, and when I powered this on, I was greeted with this screen. So yeah, it looks like the PCB is working fine. What I'll do is I'm going to hook up the old membrane now, and I'm going to press some of the pads on the membrane just to see if I get any input, and if I do, I'll go ahead and buy a new membrane. Also, what I'll probably do at the same time is buy a capacitor kit, because obviously these ones are getting pretty old now. But what I'm going to do next, after I've tested the membrane, is I'm going to mod this so it outputs composite video. So okay, I've just put the old membrane on. I just want to see if I get any reaction when I press any of the keys. So if I power on and I push a key, and I'm getting some input. So yeah, I'm happy with that, guys. I'm getting some input when I press keys on the membrane. So yeah, I'll order a new membrane. Now you may be going, why don't I just, you know, try and repair the old membrane? Sadly, this tail now is too short, so when it's actually in the keyboard, it won't reach the actual socket anymore, because, you know, they're really tight to begin with, and when that end snaps off, you just can't repair it. So yeah, I've got to get a new membrane. But yeah, it looks like the keys are working. So what I'm going to do next is I'm just going to mod the RF output so it outputs composite video. So okay, time to composite mod the Spectrum. Now the way I do it is I totally remove the RF modulator. I cut the internals out, then I add the capacitor, and I hide it inside the RF modulator casing. It just looks neater that way. It's nice and neat. You don't have a capacitor hanging out the side here. So yeah, what I'll do is I'll get this RF modulator box off and I'll show you what that looks like. But first, what I want to do is cut these two wires going into the RF modulator. This is the 5 volts to power the circuitry inside the RF modulator, and this is actually the composite video signal we need. So yeah, I'll get on with that and show you what it looks like afterwards. So okay, that's the RF modulator removed from the circuit board. What I need to do now is rip the internals out the RF modulator, so I'll get on with that and show you what it looks like afterwards. So okay, I'm about to remove the circuit board from the RF modulator. Now that's easy to do. What you'll find is it is soldered to the can and that holds it in place. Now your RF modulator might be slightly different to mine, so your solder points may be different, but mine's here, 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 and here. I removed those and the RF modulator should come out. Sorry, the circuit board for the RF modulator should come out. Now there's another thing I need to point out as well. There was a resistor here, you can see it if I move the leg of resistor up a little bit. There we go. It was connected to the actual positive side of the actual RF connector. You just need to remove that from the positive lead of the RF modulator before you can take the circuit board out. So okay, I've gutted the RF modulator. PCB came out pretty easy with my desoldering station. What I need to do now is reassemble the outer shell of the RF modulator and solder it back into place, and then I'm ready to finish the composite mod. So I'll crack on with that and let you see what that looks like once it's done. So okay, we're done. I have a nice little box now to fit my composite circuitry in. Got a nice little lid as well. So yeah, I'll crack on with that and show you what it looks like once it's done. Okay, what I want to explain now is why we use a capacitor on the composite video output. A lot of people, when they do their composite videos for the Spectrums, they skirt over this they'll just tell you to add a capacitor, and they don't explain why you need to add that capacitor, probably because they don't know what it does, to be honest. So what I'm going to do is explain what that capacitor does and why it needs to be there. Now the first thing we need to know is how the ZX Spectrum generates its video. Now it generates its video through this chip here, and that outputs the video, and then it gets buffered by these two transistors. Now when that composite video comes out from one of those transistors, it comes out with a DC offset. Now that's perfectly fine when it goes through the RF modulator. The RF modulator takes care of that, and then obviously spits out the RF signal to the TV. But because we're modding this thing to output composite video, we want to remove that DC offset. Now if you look, what I've done is I've wired the composite video straight in, and if I pan up to my TV, you can see it actually works. But what I've done is I've hooked up my scope to that composite video signal, and if we look at my scope, we can see the composite video signal. But if we look at the actual 0 volt line, this is 0 volts here, we can see there's an offset to the signal. So if we look, I'm on 500 millivolts per division. So if we count each square upwards, 1, 2, 3, about 4 squares, so 500 times 4 is 2 volts. So there's about a 2 volt offset there on the composite video. Now you're not going to damage the TV by doing it this way, but what the capacitor will do is it will block the DC, and it will bring this more down towards the 0 volt line, and it will be better for the TV. So what I'm going to do now is add a capacitor to that, and in fact I'll finish the mod on the on the composite video mod, and then we'll look at the scope again, and we should see that DC offset has probably not disappeared but gone down quite a lot. So yeah, I'll crack on with that and show you what it looks like once I've done that. Okay, I've completed the mod properly this time, how you're supposed to do it. As you can see, here's my capacitor. Now what that's done to the composite video, if we look at the TV, it's not done much, there's no change there. But if we look at my scope and we look at the composite video signal, we've pretty much eliminated the DC offset, because here's my 0 volt line and you can see it's bang in the middle of it. So yeah, we've eliminated the DC offset. Now that's what you want to try and send to a TV, a signal like that, not with a DC offset. And that's the reason why we use the capacitor, is to kill the DC offset that's generated by the buffer circuitry. So yeah, there you go guys, you won't damage your TV by just wiring it straight in, but now you know the reason why we use a capacitor. So okay, I've got the can cover back on the RF modulator box. That's now outputting composite video, the correct Composite Video. So okay, I finished cleaning the upper and lower case. I cleaned the key posts and I also cleaned the keys. Now for the fun part, putting all the keys back on. Yay! So okay, all the keys and the posts have been put back in. As you can see, it looks a lot better than it did, and another great thing, the enter key doesn't stick anymore. I gave it a bit of lubrication and it's absolutely fine now. What I've done is I've actually screwed it all back together, including the old membrane. Now the reason I've done that is because I've got to wait now for the new membrane to arrive, and I didn't want to mislay any of the parts, so I just put the keyboard completely back together. So yeah, it's just a waiting game now, waiting for the postman to deliver the new keyboard membrane. So hurry up, postie. Yay! Look what's arrived. Cap kit, new membrane. I can get on with the rest of the video now. Sweet. Okay, I'm ready to get the old capacitors out, put the new ones in. It shouldn't take me too long. I have my desoldering gun, so I should motor for it pretty quick. Before I begin, I've just got a quick tip for you if you're going to do this. If you look at a capacitor, it will tell you where the negative leg is. If you look at this capacitor here, you can see an arrow pointing towards the negative leg. Now what I tend to do before I replace the capacitor is I'll take a Sharpie pen and I'll just put a little black dot right near the negative leg, so then I know once I take that capacitor out, I know where the negative goes. So yeah, I'm gonna whip all these capacitors off, replace them, and then I'll let you have a look what that looks like once I've done. So okay, as you can see, I've replaced all the capacitors. It's time for the smoke test. So okay, let's power on. And there's no smoke, guys. And we got a picture. So yeah, I'll leave this for 5 minutes, just let it run. Just make sure nothing explodes. But yeah, looks okay. So what I'll do now is move on to fitting the new membrane into the keyboard. Okay, I've removed the back cover. I've not shown you how you do that. I've already shown you that earlier. Super easy to fit the new membrane. Job's a good one. Just got to put the back cover on and put the retainer clips back on. Okay, that's the keyboard membrane installed. Pretty easy to do. Just take the back cover off, remove the tail retainers, remove the old one, put the new one in, tighten the back cover back on and put the tail retainers in there, and you're pretty much done. Houston, we have a problem. It's me. I'm a tit, that's the problem. What I didn't realise when I was powering this thing on was it was actually booting up in 16K mode. I just totally overlooked that. Why? Because I'm an idiot. Now I only noticed it when I put the keyboard membrane back in and I hooked it up to give it a quick test before I did the rest of the filming. I powered it on and noticed it was booting pretty quick, and that's when I realised, you know what, this thing might be booting in 16K mode. So I ran a bit of a command line is that I'll put a little description at the bottom of the video, just down here, the line you can write in to find out if you're booting in 48K or 16K mode. And I did that and it came back 16K, and I was like, oh, you complete tit. Now what I did was I started looking at the signals with my scope. That's why everything's on, and a couple of signals didn't look right. So what I did was I removed the actual RAM chips, just to make sure it wasn't the RAMs that were pulling the signals down. But the signals looked the same after I removed them, so I was like, well, okay, it's not the RAM. And what I found out was the signals that looked sketchy were generated by this chip, and it looks like this chip has failed on one of its outputs. So okay guys, I've got the 74HCT32 in my EEPROM burner. I had highly advised getting one of these TL866s. They're very good guys, and you can also test logic ICs on them. So I've got that in there. As you can see, I've got the 74HC32 all selected. If I press select and we go to test, and we get an error, test error, unit 1, so logic gate 1's failed. So yeah, you little So okay, what we're looking at is part of the circuitry that controls the right RAS and CAS for the expanded RAM in the Spectrum. And what I've done is I've highlighted some of the gates, but before I take a look at those, I want to show you the data sheet for the 7432, and here it is. This package contains 4 2-input OR gates. Now if we look at the truth table, we can find out what this does. So this is an OR gate, so the truth table goes, if A or B is high, the output is high. The only time this will output a low is if both inputs A and B are low. Now if we take a look at the control and input circuitry for the RAM, the upper RAM, we can see here's the memory request coming from the CPU. Now what I've done is I've highlighted the gates that are fine in this chip. This one are fine. Now what I've done is I've highlighted the one in red. This is the one that's failed, and it's part of the M request. Now what's the first thing we see? Well, they're tying both A and B together. Now what that tells me is all they're doing is they're just buffering this M request. Now we can tell that because we know the truth table for this OR gate, because if this is high, right, one of these inputs only has to be high for this to output high, and they're tied together, so both of them are high, so this will output a high, right? Now if this goes low, this M request goes low, what was the truth table telling us? If A and B are low, the output's low. So all they're doing is basically buffering this M request with this OR gate. Now if we look at this OR gate, what does it do? If we follow the output, it does RAS, and it also goes into this OR gate, and this one generates CAS. Now because this has failed, we're getting a cascade effect, and we're getting RAS and CAS getting all screwed up. And that's what I found when I started probing on my scope. These signals looked a bit sketchy. Now the problem with this is I don't think this is just the only problem, because when I was doing checks on the RAM, I saw some other sketchiness on the address lines. So what I'm going to have to do is this chip that contains these 4 OR gates, I'm going to have to whip out, I'm going to socket, and I'm going to put a new chip in there. But also what I'm going to do is the chips that are around this OR gate, this 7432, I'm going to whip those out as well and socket those, and I'll put those back in. And then if I have any problems with any of those chips, it's going to be super easy to replace. I don't have to desolder them because they're already done. So yeah, that little git has failed and it's causing a cascade effect. But like I said, I think there's a little bit more going on here, guys, because when I checked one of the address lines on the RAM, that looked a bit sketchy as well. So yeah, I'm going to see if I can track that down next. I replaced the chip, guys, and we're still booting in 16K mode. If I power on and show you, there we go. So yeah, we found one error. Now there's another one, and I think I found out what it is. What I've done is I socketed the rest of these chips here, because I was thinking, well, okay, if this chip has failed, maybe some of these chips might have failed as well, and I'm glad I did that, because I found something else that's sketchy, and it's to do with the RAM. So what I'm going to do is I'm going to show you what I found. So if I look at address 0, so this is address 0, you look at my scope, we got nice activity there. Now if I move to the next one down, which is address 2, look what we get. Yeah, that's not right. So if I move down to the next one again, and the next one should be address 1, and you can see we've got nice activity. So yeah, there's something wrong if I put it on the next one where address 2 is as well, because don't forget these are all connected together. Yeah, so we've got something sketchy going on at address 2. So what I'm going to do is I'm going to have to track that down, and then once I find if there's a problem, well, there is a problem, once I find it, I'll come back and let you know what I find. So okay, I've done a bit of continuity checks, and I found where the address line 2 is connected to. It comes from this chip here, and if we count the 4th pin, so 1, 2, 3, 4, I've got my multimeter on continuity. Hopefully you'll hear it beep. So yeah, so that's where address 2 is originating from. So what I'll do now is I'll get my scope on that, and we'll see that sketchiness again. So okay, we know address 2 originates from this chip here on pin 4, so let's probe that. So 1, 2, 3, 4, and we should be able to confirm that sketchiness. Yeah, there it is. That's not right. So what I'm going to do now, guys, is these two chips are identical. So what I'm going to do is I'm going to swap these two chips over, and I'm going to see if address 2 fires back into life. So I'll just do that, and then we'll have a look at it on my scope. So okay, I've swapped those two chips. Here they are. Just swap them over. What I'm going to do now is just look, see if address line 2 is back. So let's check address 0 first, just to make sure we've got address 0. Yep, we've got address 0. The next one should be address 2, and let's have a look, see if it's back. Yep, there you go, it's back. And the next one should be address 1, and what do you know, we're back in business. So yeah, that chip looks to be knackered. Okay, if we take a look at that TTL chip, what is it, 157 it is, 156, 157, here it is. This package contains 4 2-line to 1 data selectors. So, and here's pin 4, so Q's and output. Yeah, Q's and output. So we've got a select line, we've got 2 inputs and Q's and output, and that's the one what's failed. So the output's failed on that chip. So okay, you may be wondering, now that faulty chip is in the bottom left socket, what does that supply, that faulty pin 4? And if we look on this RAM chip, I'm actually probing address 5. Now if I once again do a continuity check, there you go, you can see they're connected. So now it's addressing address 5 on the RAM. So what I'm going to do now is test that and see if we got that sketchiness on address 5. Okay, I'm ready to probe address 5, so let's do that. It's this one here, which I did the continuity check on there. Now if we look at my scope, there it is, there's a sketchiness. So yeah, that confirms it. this chip is bad and needs replacing. So okay, I've got the faulty chip back in its socket. I might as well just leave it there. It's not going to harm anything. As you can see, it's booting in 16K mode. So yeah, what I'm going to do is I'm probably going to get replacements for all 5 of these chips. Obviously I've already replaced this one, we found a fault there. This was the same manufacturer as these, and this one's the same manufacturer as these as well. And I don't trust this manufacturer. It's a Billy No Names manufacturer. So I'm probably just going to replace these 5 chips for something decent. So yeah, hopefully when I get those replaced, it fires back into 48K mode, because if it doesn't, it's going straight out the window. So okay, what I want to do now is blow the myth out of the water that you need an expensive oscilloscope to do this type of work. You actually don't. You can get away with a £20 logic probe. I've had this logic probe so long, I can't even remember when I got it. It's that long. But I can remember I paid around about £20 for it. I remember that. Now, the way a logic probe works is when you probe a pin, it will tell you what the pin is doing. So it will tell you if the pin is high, if the pin is low, if the pin is floating, which is basically doing nothing, or if the pin is pulsing. Now what I'm going to do is show you that. So if I probe this pin here, I know this pin is ground, and you'll see a low come up on the probe. There you go. If I go to the opposite corner, I know this is a high. This is VCC, so this is going to be a high. And as you can see, the probe is showing a high. Now if I probe one of the pins of the chip, let's see if we can find one that's pulsing. Yep, there we go, you can see that's pulsing. Now if I was to probe a pin that's floating and I just touched it, this is what would happen. You would see nothing like this. Now the one thing you can't check with a logic probe is the integrity of the signal. Now you would do that with a scope, and that's where the scope comes in. So yeah, this does have limitations, but what I want to do is show you how you would find a problem like what we found here with this address 2 with a logic probe. So what I'm going to do is I'm going to probe address 1. Now remember, these addresses should be pulsing along quite nicely. So if I probe address 0, we can see the logic probes pulsing. Now if we go to the faulty address line, this one should be pulsing as well because it's an address line. And so this is address 2, and as you can see, it's low. That should be pulsing just like this one. Now if we go down to address 1, and we're pulsing, so address 0 is pulsing, address 2 is stuck low, address 1 is pulsing. So with a £20 logic probe, we've just found a problem with one of the address lines. So okay, I went out, got myself a 74157 to replace this faulty one here. So let's go ahead and do that. Let's replace this faulty IC because we already know it's bad. Okay, that's the faulty one out. Let's put the new one in. Make sure we're in. Okay, let's power on. See what we get. That looks like 48K mode to me. You could tell with the delay on the boot up, it was stuck on that black square and then it decided to boot. So what I'm going to do now is on these 4Bs you can reset the system by bridging across this capacitor. So that's what I'm going to do, and then we'll take a look at how the system boots. Yep, that's 48K mode. Ah, thank you. I can move on now and do the rest of the video. So okay, now we're booting in glorious full 48K mode. I can point at what chips failed. This multiplexer, this 74157 had failed, and this 7432 OR gate had failed. Now if we take a look at the schematic, I've highlighted the chips that have failed. Obviously I've already shown this one had failed, this gate had failed inside this chip, and that's the 7432. Now if I move up, I'll show you the multiplexer that had failed. This multiplexer, this 74157 had failed as well, and that's these two chips here, and that's what was killing the 48K mode. Now I was going to replace, I was going to replace these chips as well, but I've decided not to do that. I've got these chips anyway, so if they do fail, I can always replace them. But yeah, that was a bit of a pain. I wasn't expecting it to be that bad. Maybe one chip had gone, but yeah, both of these two chips have failed. Okay, now because this system was missing its reset switch, which should be in there, I mean it's a plus model, there should be a reset switch just here, but because it's missing it, I'm going to have to install one. Now what I'm going to do is I'm going to drill a little hole right next to the original reset mount. That way I can, if I ever get an original one, I can just put the original one back in. But what I've got here is a little push to make switch, and like you saw when I just fixed the system, if you bridge that capacitor, you can invoke a reset, and this is what the opposite end is going to go on to the motherboard. So yeah, I'm going to drill a little hole here and then mount this reset button. So okay, as you can see, reset button is installed. I went for a nice blue one. Now the reason I chose blue is because blue is my favourite colour, and it's got absolutely nothing to do with the fact that I broke the end off the red one. Tit. So okay, what I've decided to do, guys, is I'm actually gonna screw this board in. I've got some small screws, I'll show you one of them there. It's only tiny, and I'm gonna put them in these 4 places here. The reason for that is because there's nothing holding the board. You know, it can just move about freely, and I don't quite like that. So yeah, I'm just gonna put some screws in these 4 posts here. They shouldn't go all the way through, and yeah, I'll show you what that looks like once I've done it. So okay, my reset switch is installed. I've screwed the board into the case now, so it doesn't move about, it's solidly in there. Also, what I've just done is, remember the broken post, I fixed that. I just put a bit of plastic underneath there and then glued it all back in. Hopefully that should be a bit more robust now and not break off. So yeah, what I'm going to do now is get this system all buttoned back together, and we can give it a test. Finally. So okay, all buttoned back together, ready to test the system. What I'm going to do now is power on, and hopefully we should be all okay. That looked like it booted in 48K mode. Now the first thing I'm going to do is test the reset button, and I'm going to press it now, and yeah, that looked like a 48K reset. What I'm going to do now is press some of the keys. I'm going to start on the 1, see if we get keys. Yeah, we got keys. I'm not going to test all of them, guys, but see, now it's a new membrane, I don't see how there's going to be a problem. What I'm going to do now is I'm going to just type out the command to test, see if we're running in 16K or 48K mode. I think we're running in 48K mode. So what I'll do is I'll write that out, and when I'm ready to press enter, I'll come back and show you it. So okay, I've written out that basic command. There it is. Now when I press enter, I should get a number back from the Spectrum. Now, depending on what value number that is, that will tell me if the system is booted up in 16K mode, please God no, or 48K. Now, the number I'm going to be looking for, if it's 16K, is 32767, and if it's 48K, is 65535. So, moment of truth, guys. Let's press enter and see what we get. Yes, there it is. 65535. We're 48K, baby. So what I'm going to do now is I'm going to hook up a tape deck to this and see if we can load a game, and then I can finish the video off. Whee! So okay, I'm ready to go. Let's see if we can load a game on this thing. So I have the audio in, going into the ear of the back on the Spectrum. I have the audio out, coming out of the tape deck I reconditioned in the previous video for the MSX. So yeah, let's power on. Yeah, we still got 48K mode. So let's load, which is J, and come on. Okay, we're ready. Let's press play on tape. And hopefully looking good so far. I think we nailed it, guys. I love that bit. Yeah, so what I'll do now, guys, is I'll let this game load, and then once it's loaded I'll come back. So okay, did it load? Well, let's have a look. I'm happy to say it loaded first time. Oh, you don't know how relieved I am. So yeah, guys, there you go. It was a long one, but we got there in the end, and it's turned out really nice. So we've got a nice Spectrum plus 48K. So yeah, I hope you liked the video, guys. Please give it a thumbs up, like, comment, subscribe, all the usual stuff, and as always, I'll catch you on the next one. Yay! Suck it.